Well, good morning, everyone. My name is Scott Shadley. I'm the VP of Marketing here at NGD Systems. We're going to be presenting some information to you today from NGD, from our partners at AnyLog and AI Ops related to computational storage deployments. So I'm joined today by Ellie Tiomkin, my VP of Business Development here at NGD. We'll hear from Moshe Shadmon, the CEO and founder of AnyLog, as well as Philip Hansel, the CEO and co-founder of AI Ops. We appreciate you joining us today and look forward to sharing this information. If you guys have any questions or comments that you'd like to put into the questions window, we'll be happy to address those in our Q&A session at the end of the presentation. As far as the planned activities for today, I will walk through a brief overview of what's driving the need and interest in the concepts of computational storage and the value that it will bring to the marketplace. Ellie will give you a quick rundown of the products being used in this particular demonstrations that we'll be providing from NGD. And then we'll also have an overview and demo from our friends at AnyLog, as well as another overview and demo from AI Ops, and we show you how all of these products work together. And at the end, we'll wrap it up with how to get access to this set of materials, the set of products, and also answer any of the questions that you have related to this particular webinar and presentation. So we'll do our best to save most of the time for the actual demonstrations and walk through some content for you. So as we all know, edge compute has very different definitions in the market. We start at the cloud, which of course is our friends at the big 8 data centers for the most part. We have the near edge, what some people also call the edge nodes, and then we have the far edge or devices at the edge. All of these products continue to get more and more intelligent no matter how far away from the quote cloud or home location of the data or algorithms that we're trying to drive, whether it's your refrigerator that can now special order your eggs for you versus your car driving down the street or just simply your smartphone. So the ability to continue to improve the synergies of compute, storage, and this data that we're generating and the value of the data that we're generating is more and more important as we move forward in our architectures, in our lives, and in the way things are moving in technological advancement. And part of what's causing this, of course, is we've got all these cool new devices, so the amount of data that we're generating is what we're calling a data explosion. Every 3 years, it's doubling the amount of raw data that we're generating. Now, this is a great thing for a guy like a storage company, but for people that are trying to utilize that information from the data, we need to find a way to make sure that we can get meaningful results from this exponential growth of data. And that's part of what drives the need for something like computational storage. Putting the processing power closer to the raw data allows you to get faster results from that raw data, which also allows you to be able to generate value from that in a much more efficient and effective way. And so the fact that we are seeing this continued growth, and the 175 in 2025 was recently revised to over 200 zettabytes of data. That's a lot of information that has a lot of noise, that has things that need to be done with it. And there's great opportunities. And we're going to show you some great examples today of what's going to resolve that or help resolve that as we move the market forward. As far as the edge computing architectures we have and know and love today, you can see that the type of platforms that we're dealing with, it's not just software. Software is a massive important part of this, but the actual hardware behind it is also very valuable to these particular solutions. So we need to make sure that the synergies of these technologies work very well together as we see this explosion continue to grow in just specifically the edge compute market, as shown here by our friends at Grandview Research. A 38% CAGR is a pretty impressive CAGR. We need to make sure that all of the technologies work around that. We're pushing forward with all this concepts around the idea of going carbon neutral, things like that. All of these play into how this exponential growth of information is continuing to drive technologies and architectures forward. So brief overview, a quick introduction. I'm going to now take the time to hand it over to Ellie, and he is going to give us a quick rundown of the NGD solutions, as you can see shown here, and what we can do with those as the market moves forward. So Ellie, if you'd like to join us.
Yes, thank you, Scott. Thanks for the overview, introduction about edge compute and some of the ecosystem in the market. So what I will try to focus today in my section, which is the hardware section, talking about the actual storage, is talk about some of the storage attributes that are needed for edge computing and some of the compute efficiencies that are needs to be resolved with the way the infrastructure is set up. So let me move to the next slide. There it is. So the problem that we see around edge compute is because of 5G and IoT and all that data explosion that Scott mentioned, there's problem in having enough capacity at the edge to store the data. And then there's a problem around latency for processing the data and around data movement. If you have a large amount of data that is now stored in your storage, anything you need to do with that data, you need to move it back and forth in chunks to the host for processing. And that data movement is painful in terms of performance and in terms of power. So the solution that NGD has for these problems are divided in two main buckets. The first one is from a storage perspective. NGD is making an NVMe storage device. It's a standard protocol, but with unique features to solve edge compute problem. First of all, the latency. Quality of service is best in class. The second thing is our watt power consumption. So watt per terabyte is very, very good, which is a very important feature for edge. And the third one is the actual volumetric density. How much storage can you squeeze into a particular form factor? And just as a point of reference, we have a 32 terabyte that is in a U.2 form factor that requires only 12 watts. So those are very important features for edge compute infrastructure. The other part of the solution is around the compute. So having unlocking the value of the data by not moving it, bringing the compute to the storage rather than moving the data back and forth from the storage to the host, to enable AI, machine learning, and I'm going to give a few examples. And most importantly is seamless programming model. So the ability to implement an application or a machine learning process or AI on the computational storage without the need to change anything in the operating system or implementing drivers, a very unique and simple way to do those things. So next slide. Here's an overview of the NGD Systems solution as it is today. So first, we rely on our own SoC. This is a 14 nanometer, 16 channel NVMe controller. That's the heart of the product. Next is the actual products. We have U.2, M.2, E1S, so different form factors to fit different needs at the edge. Then to make these products work smoothly, there's firmware, and it's our own firmware implementation that takes care of the device as enterprise-grade SSD. And last but not least is the software stack that enable the actual computational storage component. And I'm going to dive to that in the next slide. So next slide, please. Here I have a very high-level overview of a computational storage and how it operates. So on one side, we have the host. We have the CPU, GPU, and the operating system where the application runs. This is on every compute systems. On the other side, we have a diagram of our SoC. And as you can see, there are many of them. So if a server holds 4, 8, 12 drives, we have the luxury of doing the distributed processing in parallel. The media controller is what you'll find on any enterprise-grade NVMe SSD. The purpose of the media controller is to communicate the NVMe protocol to the front end, to the host, and on the back end to take care of the NAND, the wear leveling, the garbage collection to make sure that the NAND behaves as an SSD. What makes NGD Systems NVMe SSD unique is the other part, the other plane on that same controller that has ARM core and have a local operating system, Ubuntu, that is running. So now the host is looking at the drive not just as a block storage device that you can read, write, and erase at a very fast rate, but also as a microserver, because you can take the application, recompile it, and run it within the storage. So it can be an application, it can be a container, you can execute a code, and you can easily change from one thing to another or have a few things in parallel. And that orange arc you see is actually TCP/IP tunneling through the NVMe protocol. So we use mature existing technologies in the market to enable computational storage. And if you're interested in more details how we enable the computational storage, we'll be more than happy to have a deep dive separately. And next slide. So some use cases. Let's talk about use cases. So here you have a CPU, memory, and servers with drives, with computational storage drives. So some of the use cases is you can take a database and run it inside computational storage drive. Databases like MongoDB or Apache Parquet or Hadoop. You can run Elasticsearch. If you're looking for image processing or video analytics, you can run it inside the drive. Towards the end, a few applications that we have optimized to run inside our computational storage devices. A few examples are the Microsoft Azure IoT Edge that runs inside our SSD, the AWS Greengrass that runs inside our Edge. On the VMware, we have both the Tanzu and the Greenplum databases that running inside our computational storage. And for today, I circled both AnyLog and AI Ops that will demonstrate how they run their software and their uniqueness inside our computational storage devices. So we bring the platform, we bring the ability to take compute and run it inside the storage, and then it's up to the end user to decide what type of advantages do you want to do, what makes sense of screening the data where it is in the storage instead of moving it back and forth. So before I move it to Moshe at AnyLog, the two main key takeaways that I want you to take from my part of the presentation is one, from a storage perspective, the volumetric density, watt per terabyte, and quality of service are very important at the edge. And NGD has a unique solution on that part. The other thing I want you guys to take away is the computational storage part, the ability to run the application, the AI, the machine learning on the data in the storage where it resides instead of moving it back and forth. So thank you for listening, and let's move to AnyLog.
All right, now we're going to hear from Moshe and the AnyLog side. So we'll let him go ahead and continue the presentation. Again, if you have any questions or would like to put any thoughts into the question and answer session, we'll be happy to address those as we approach the end of the webinar.
We're excited to partner with NGD Systems and AI Ops to deliver an end-to-end solution to oil and gas. I prepared a short presentation and a demo to explain how AnyLog is deployed on the NGD nodes at the edge. AnyLog deployed on NGD transforms the distributed NGD nodes to operate as a single unified machine that makes the edge data available to the applications in real time without moving the data to the cloud. Philip, who will be talking after me, will demo the AI Ops Edge AI application. The AI app is integrated with AnyLog and uses edge data in real time to control an oil and gas production line. There are 2 points which I want to highlight in the demo. The first is that all data management from schema creation to storage and unifying the data is automated. The second is that although the data is distributed on many edge nodes, using virtualization, data is available to the applications through a single point in the same way that centralized data is available. This approach eliminates the need to bring professional services to the edge and the need for proprietary software. I'll use this diagram to explain how it works. On the left side, we show a production line. NGD provides computational storage at the edge, and the first step is to deploy the AnyLog software on the NGD nodes. AnyLog on the edge provides all the needed functionality to manage IoT data. All that is needed is to stream the data from the PLCs and sensors to the node. When data reaches the node, AnyLog is able to associate a schema to the data and store the data locally. Obviously, there is more data than what a single node could manage. And to address the data generated, we could add as many nodes as needed, and each one of these nodes could host data. These nodes form a network that is optimized to manage IoT data. The nodes leverage a shared metadata layer. The shared metadata can be hosted on a blockchain or on a dedicated node. And the outcome of the shared metadata is that all the nodes process the data as if they are a single machine, allowing schemas to be shared across all the nodes such that applications interact with a unified collection of data. The metadata layer is completely transparent. It does not require significant resources and is operational with zero maintenance. To this setup, we add one or more query nodes. The query nodes are the access points to the data. Applications only see a query node, and using virtualization, the query node represents all the data that resides in the edge nodes of the network. With this approach, an application issues a query to the query node, and the query node replies as if all the data is hosted locally. The query is resolved by pushing the query from the query node to the storage nodes that have the relevant data, and unifying the results returned from all the participating nodes such that the application received a unified result as if the data resides in a single database. This approach is very efficient, as rather than moving the huge volumes of data to the cloud and managing large databases, we only move queries and the results over the network. Therefore, queries are satisfied with massive parallelism and therefore in real time, and the process is fully automated. We will now show the demo. In the demo, Grafana is connected to the query node and shows a unified view of the data, which is hosted on the 4 NGD nodes that are used for storage. We will use a GUI to show the status of the data and the nodes from a single point. And Philip will demo real-time Edge AI over the edge data. I'll switch to the demo screen. Grafana is connected to the query node. The query node describes to Grafana the entire collection of data as if the data is hosted on the query node, although physically the data resides on the storage nodes. You could see the graph on the top showing the mean, max, and average values of the sensor data using the last hour. You could also see that the graph values changes as the 4 operator nodes receive a continuous stream of data. The top gauge shows the data inserted in the last hour in all storage nodes, and the bottom shows per each storage node. However, Grafana interacts with the data that resides on all 4 nodes as a single collection of data. You could see the source data that generates the graph. On Grafana, the user could see the list of databases and tables on each database. We could select any type of data that is hosted on any node and query the data as if it is hosted on the query node. A selection of the different table will bring different sets of data. All of that was done while keeping the data in place without a single line of code. If the same data resides on multiple nodes, the shared metadata enforces a unified schema, and the data appears to the Grafana console as if it is a single collection of data.
I'd like to thank Moshe for that overview and update, highlighting the capabilities of the AnyLog platform and how it interacts with all of the different devices. At this point, we'd like to now hand over the presentation to our friend Philip at AI Ops, and he'll go ahead and walk through some content for you as well. So welcome, Philip. There we go.
Yep. Thank you, Scott. Yeah, so to give you guys a brief overview of AI Ops, we're a company just structured around bringing machine learning solutions to control systems problems, specifically to oil and gas companies, agrochemical, bulk chemical, where some really prime and premium data already exist, right? So we're looking to go after that prime market. and sort of tie together the old data stores that they have and then implement some real-time solutions for them. So let me see if I can grab control here. Or Scott, if you can roll to the next slide for me.
Sorry about that. You have control now.
There you go. Perfect. All right. So, today's control systems, although they are modern and these companies have spent millions of dollars updating to the most modern electronics, they still deploy the old control mechanisms, single input, single output, what we call PID algorithms. So given a single set point and a single input drives that value to make some control output moves. And although effective at controlling a set point, it's not the most optimized to stabilize the overall process or to respond to upsets. So what we're looking to do at AI Ops is sort of close that gap between, you having the modern electronics and being able to actually deploy modern control schemes, something like deep reinforcement learning models to other AI type models. So AI Ops actually makes it possible to do that. So what we're saying as a company is keep your current electronic investments, your DCSs, your PLCs, your SCADAs. We're going to build you a software application that can install on some off-the-shelf hardware that can link up to that system, pull your data across, make use of it right where it's at, and then return the executed outputs back down to your system, either for anomaly detection or most impressively for control, which we'll demonstrate for you here today. So the way in which we decided to do that is to do it at the edge. A lot of these big companies that are running very critical infrastructure for all of the world really don't want their data quite leaving the site yet. So we were developed and built with the edge in mind and living within their fence line. So we have a predict engine and a training system that can live at your site. It installs again on off-the-shelf software or hardware. And the software comes, built in with all the features ready to deploy on your system reliably. We've got some safety mechanisms built around the control scheme, which you'll see in the demo. And the maintainability of it all is also put together with that concept in mind. Everyday engineers have a lot to deal with. The last thing they want to do is have to roll through a bunch of clicks to update a model. What they want to do is solve the problem and go home. So what we like to say is we want to give you those solutions, those machine learning solutions, in as few clicks as possible. So what you're going to see here is just basically the difference between normal PID control. So just here on the left-hand side of the graph, you can see this is normal PID. This is optimal control for most systems. If an engineer today was to look at that, they would say, okay, that's not bad, right? It's the green line down there at the bottom is somewhat staying close to the little magenta line, even though the process is swinging pretty hard. But the moment that you enable AI Ops control, look what happens to the process. Basically, we flatline it. We're doing something that was thought impossible prior to us implementing this control strategy. We have done this in the real world, so this is not just a bench test. We have optimized a hydrotreater system in oil and gas recently and have published a press release with that company. So you can actually take a look at that press release on LinkedIn. I can email you the link if you're interested and take a look at some of the results. But we definitely optimized their process, took about 120 engineering hours. So very, very cost effective when you're talking about advanced process control solution. So now what I'm going to do is kind of jump into the demo and sort of rope all of this together for you. So we've got NGD computational storage. We've got multiple nodes. We've got AnyLog software installed on each one of those nodes. Our system is going to take in data from a control system and basically store that data off onto the CSDs provided by NGD using the AnyLog network. We're going to be doing control all while we're doing that. And then we're going to leverage that data that's on those nodes to actually retrain a digital twin together and then update that model on a live control system. So hopefully you enjoy the demo here coming up, and would love to hear any questions to follow. Thank you very much.
All right, so now we're going to jump into the demo session. What you guys are looking at here is a standard representation of a generic process. This is provided by Inductive Automation's Perspective Web Graphics. So it's a very useful tool, works great with the AI Ops controllers, can serve OPC UA data, SQL data. Plenty of data can be brought up here to the front. So that's what we're using here to serve up to the screen. And what you're noticing here is that we've got 4 flows coming into a single tank, and we have a control valve here that's controlling the drain rate of the tank to hold the level at a steady state. All 4 and 5 controllers that you see here are all in automatic. So they have standard PID functions behind them, operating as all other controllers operate out there in the industry. So what you're also going to see here that looks a little different than normal is you have these AI PV calculations, which are digital twin models running in the AI Ops controllers, predicting the flow rates based on current valve position. You'll notice that some of these are pretty accurate, whereas some of these are not so accurate. For example, flow 13 seems to be a good bit off from the predicted number versus the actual flow rate. Some other things you're going to see down here on the drain controller. We are again predicting the level that it should be based on the flow rates coming in and the valve position letting the flow go out. And we're also got this extra piece here called AIMV, which is the AI controller output. So what we're going to actually do in just a minute is actually enable the AI Ops controllers, the predict engine, to take over control of the drain valve and optimize the flow coming out and basically flatline the level in the tank. So let's take a quick look at what we're doing and how AnyLog and NGD plug into this. So this is, we have 2 AI Ops predict engine controllers, one on IP address .10 and then the other one here on .8. Each one of these predict engines has got multiple models running on them at one time. You can see here the flow 13 digital twin, the level digital twin, the level controller, and then over here on the .10 controller, we're predicting the flow 11 and flow 12 with digital twins. On each one of these controllers, there's a set of protocols enabled. Here we've got the AnyLog setup, Modbus TCP, and OPC UA, which is connected down to the PLC device that we're actually pulling the data from. So we have a nice back-off PLC that we're pulling data in from, and we are also connected to an AnyLog storage device where we're both serving data to and pulling data from. Once you basically set up and build your devices, you're able to assign tags from those devices. So I can pull tags in directly off the AnyLog network, or I can pull tags in off the PLC network and then serve them back out to AnyLog, which is what we're doing here. So if I jump into flow 12, I can see that he's being brought in here from the back-off PLC, but I'm also giving him remote access to be published back out to the AnyLog system. If I click here and take a look, I'm now looking at the AnyLog data on the AnyLog node, and I can swap back to the back-off, and here's my local data here that I'm storing locally from the back-off PLC. So the integration is super tight, super smooth, able to get data in, out, store it, and then use it. So now let's jump over here to .8 where things get a little more interesting. So what we're doing here is we have a similar setup. We've got some devices here. We're also connected to an AnyLog NGD setup. So we're connected to several sets of NGD nodes, all with AnyLog storage software on it. We're connecting to each one of those and sending data to each one and pulling data from each one. Again, we're connected to another back-off PLC as well as to the other AnyLog node device on .10. So we're looking at AnyLog data from NGD, and we're also looking from AnyLog data from a separate network on .10. So I can pull data from just about anywhere. Jumping over here to the tags, we see just that. We see that I am pulling data from .10, and I'm also pulling in data from the PLC and then publishing it right back out to the NGD system. If I jumped over here, we see the same sort of setup as we did before. Tags coming in on the PLC, and I'm pushing them right back out to the AnyLog NGD storage system. So how do we use this data? So we're pulling it all in. Obviously, we're taking the PLC data and we're binding that data to these pre-trained models, and we're executing them right here on the edge and delivering control outputs and digital twin predictions back down into the PLC system. So if we jump back over here to my graphic, I'm just going to enable AI control. Just like that, with a simple button click, we've now enabled AI control. What we're going to do is jump back over to the AI controller here and take a look at his data for the last 30 minutes. So for the last 30 minutes, these are all the flow values here. You can see the flows are all over the place. And for the most part, the level's holding its set point. It's doing what normal PID loops do. But whenever there's a big upset, you see that we get a pretty decent ripple here. So what we're going to do is let the AI controller run and do its thing while we're running the rest of our demo. And then we'll come back here and take a look at it and see what it's done. So we've got the ability to execute AI controllers at the edge. Now what we're going to do is actually train some digital twins here from the edge. So we're going to use that data that we're storing off with the AnyLog system on those NGD computational storage devices, and then we're going to optimize or try to make our model for flow 13 better. If you remember, flow 13 was the flow that has the pretty big deviation between the prediction and the actual value. So let's see if we can't make it better. If we jump in here to the digital twin builder, we can check the session history. You can see that we've gotten some pretty nasty models made. 16% error, 20% error, 15% error. It's kind of all over the place. We've made it a little bit better here. If you jump down here to the tags that we want to train from, you can see that we're pulling them from the AnyLog NGD system. And we've assigned a target, which is we're going to predict flow 13's process value, or PV. So we're going to take the valve input, we're going to take the flow, and we're going to learn how the flow should be based on that valve output, and then we're going to try to predict that process variable. So the first thing we're going to do is take a look. We've got a wide variety of training sets here, and we've got one validation set. A validation set is a set of data that the trained model has never seen before. Hence, that's what we validate against. And if you come over here and take a look at it, you can see that it didn't do very good the last time. We had a magenta line here, which is the predicted value, versus the blue line, which is the actual value. So you can see that we did indeed have that deviation, which is exactly what you see reflected here on the screen. So how do we make an improvement to this model? You can actually make changes here to the configuration environment. We can add the number of epochs that we run. We can, shift the data that we actually look back against on. But what we're going to do here is just simply add some more data to the system. So we know that we're going to plug in and check those NGD storage devices. So I'm going to jump back and get the last 30 minutes of data. And if we sit here for just a second, you can see that it'll go back, get the last 30 minutes. I like all of that data. So I'm going to select the data that I want, hit confirm, and then come right over here to retry and go out and train the system. You can see here that it's kind of populating its way through the AnyLog system. So it's pulling the tag data for each one of these time frames that we have specified here. And it's going to go through and start training the digital twin. We are going to do 250 epochs, and we are looking back at 5 seconds. So this is going to take about 4 to 5 minutes. In the meantime, let's take a look at some other things that were going on here. If I were to jump on to the AnyLog API tool built into our system, go through and assign the device that we want to take a look at, and of course it's the AIOps database, and I want to query some of that data that's out there. Jump here, and let's say I want to take a look at, let's do the average for the last minute. So if I come in and pull this data here, we're actually going to go out and get the data off the AnyLog system. And there we have it. So we just went and pulled all the data, and the average flow for flow 13 over the last minute was 71.74 gallons per minute. You know, you can run all kinds of little test queries here against the nodes. We can come through and check the blockchain configuration. So just how many devices am I storing on for AnyLog? So if I jump over here, I've got 1 operator node, 2 operator nodes, 3 operator nodes, 4 operator nodes that I'm storing on, all of which are NGD devices, all of which are housing a large amount of data. So if I come over here and check the table list, this is all the data that's being stored on those devices. So I'm making one single query, broadcasting that out against the blockchain, and getting one unified result back. So basically making use of your data right where it is. You don't have to migrate it to a central data store. If we check the cluster table, for example, I can take a look at it and know what data is on what cluster. So we can kind of get an idea of just how complex this system actually is. So it's very, very useful. It makes a lot of sense to kind of use the data right where it is. The trouble has always been on how to unify the query results and get that back to a single point. All nice and neat the way we want it. So that's kind of where AnyLog is coming in, fixing those things for us. Plenty of other useful things that we can do here with the setup. We can run the queries, which we've taken a look at, check the statuses, so we can just really quickly pull the status of the node itself. Looks good. Check some of the processes that are going on, get some of the detailed information off that node and off the system. We can check the error logs, the event logs, pull all that information in right here and get a good look at what we're doing. We can even take a look at some of the last queries that I've ran, which are pretty interesting. If I've had any errors over the last couple of days. So let's see where we are in our digital twin. So great, we're stepping through our validation. It's about 14% done. What we're going to expect to see when we validate is hopefully that we get a result that's a little tighter than 15 or 20% error. And then we're simply just going to update the model right here on the predict engine, and that's going to show itself up right here. And then before we close out, we'll do a couple of little unique things with the predict engine and showing how robust they are in handling the control of the system and how it interfaces nice and neat with the PLCs, DCSs, and SCADAs that are already out there. So we're stepping along. Just come in here and take a look. We're only doing one validation set. So another thing to know is, let's say we have 24 training sets and we want to do 3 or 4 validation sets against those. You can do that on this system. You can do multiple validation sets and get results for each one. So if you have one set of data that looks pretty good that you want to validate against, but you also have this other set, you're welcome to do that here on this system. It's all automated, all taken care of for you. So jumping back into this system, let's take a look and see just how easy it would be to add one of the tags that I already have in here that isn't on a remote system. So right here you can see that the status for this model is actually just being pulled from the PLC, and we haven't actually stuck it on a storage device. Because I'm connected to two different AnyLog endpoints, I can actually store this guy on one or both if I wanted to, but if we wanted to publish it out to the NGD system, we'll hit confirm. So adding the tag to a remote storage is just as easy as a button click. If we give it a minute, it should go green. Yep, there he goes. So he is now stored on the NGD system via the AnyLog device. We're almost done. Wonder what we're going to get. So once we're done here, you will get the results and you'll get a little download tab. So if you like the results, you like the validation set, you simply just download the pre-trained model file and you're able to reuse that right here on the system. All right, so we got 13%. Let's do it. It's better than the others, so we're going to go ahead and download. You can see that we downloaded model, version 5.h5 file. So we're going to jump over here to our nodes. Our AI models. Turn this guy off. All right, he is indeed stopped. Go to my settings and find my Model 5 with today's timestamp on it. Confirm. Re-enable the model. And just like that, we've taken data that we've stored at the edge. We've pulled that data from multiple sources. We brought it here, we trained that data, and then we uploaded it here on the system and made a small improvement on our digital twin. So with that kind of seals the deal with each one. You'll notice that this guy actually went out of AIOP mode and back to auto. The reason being is because we actually depend on this guy's model status. So if my digital twin is running and he's watching this flow, this guy knows whether he's watching it or not. And if he's not watching it, we're going to say, hey, we don't want to be in AI mode right now because we can't verify how the system's running. So there's multiple guardrails that we put up against these controllers to make sure that they're robust within the system. Just real quick, I'll do a quick demo and say that, you know, if our training set, the set of data that we actually trained on was good between, you know, 0 to 50 gallons a minute, and I hit good. Do I want to run narrator? No. And I hit good here. You'll see that this guy steps out, I get the alarm, and if I jump back over here, I get the alarms. It went back to auto, and then we've given ourselves indications as to what's going on. So the predict engine sends the statuses down into the system, and then there are logic choices based on what's happened to protect the system and put it back under control. So we'll go back and make that correction and get that fixed. Put him back to 150. No. He will self-correct, and we can jump back into events. We can actually see how many times we ran in that scan. Model should be self-corrected, and then when we jump back into the graphics, it's gone away, and we can go right back into AIOP mode again. And just real quick, just in that length of time that we were running, here is the result of running in AI control. And then here, immediately when we trip out, you can see that the wave has already started when we were in PID control. So if we back that out and look for the 30 minutes, this is what we get. Non-AI control, AI control, flat. So that's what we're looking to do. We're looking to not only do anomaly detection, but we're looking to do you know, high-level optimization with deep reinforcement learning models. You know, we're using NGD data stored through the AnyLog system to come back and revalidate digital twins directly on the edge and redeploy those out. So looking forward to hearing some questions. Hope you guys enjoyed the demo. I'm sorry if it went a little long, but there's just a lot to show here. So really appreciate your time and consideration. Thank you.
All right, so now that he's done the demo, we wanted to make sure people, before we jump into the Q&A, have an idea of how we can put this all together. So Philip has put together a little bit of information for us to highlight how we can put this on a platform for you, and then we'll get into the Q&A.
That's correct, Scott. Thank you very much. So the question should naturally be, you know, okay, that was a really good demo. How do we get the install to happen? In oil and gas, in agrochemical, chemical, bulk chemical, these industries are very complex. We do have a set of, or a reseller network that we operate through. These are trusted systems integrators that understand the technology, that can do the complete engineered package for you. So, you know, anything down from MOC work to HAZOP reviews, any study that you need to get done prior, getting the data off the network to be able to train, to build the models, network architectures. That's where the systems integrator reseller comes in, the reseller installer. So we have a list of those that we can provide to you if interested. A lot of the customers that we talk to have their own preferred systems integrator already on site. So they're not interested in bringing in somebody from the outside to kind of step on the toes of their existing relationships. If you have that kind of a relationship with a systems integrator, that's not a problem. We will step in and work with them directly to kind of get them onboarded as a reseller installer for you. And that way you have an embedded solutions provider right there at your site. So that's pretty much how we roll. I mean, we want to work with industry professionals to give you a really good, clean install, and as well as give you support moving forward into the future. So thank you very much.
All right, so we'll go ahead and move into the Q&A. We do have, let's see if we can get the video to come back. My computer's freaking out a little bit. There we go. So you got the four of us online to chat about some Q&A pieces. We do have some questions in the Q&A window, so we'll put it back on the video screen so we can have a nice view of everybody. One of the first questions we have in the Q&A section is, do you support HA environments, and what happens if a query node fails?
Yeah, so on the AnyLog side, every time data is being pushed to a node, the protocol is such that there are multiple copies of the data, and this data is actually shared among multiple nodes. So if a storage node fails, then the system continues to run with a different node that has a copy of the data. And on the query side, the query node is actually stateless. So if a query node fails, it's very easy. You just connect to a different node and continue to work. So we could give you on this setup complete HA and a setup such that if a node fails, the system continues to run.
Thank you for that. We do have a question from Frederick Johnson. He said, Philip, did you use the AnyLog on your computer for the live demo, or was it actually reading through the NGD on the server? He sees real time, just wants to know if the information during the demo consists of the edge to your computer or from the edge to the servers and cloud.
Oh, I got you. Yeah, so the test network in this case was using real hardware. It was not running locally on my computer. So we had a test network that we co-set up with NGD, AnyLog, and ourselves. So we were actually pulling data southbound from the PLCs to our predict engines and then publishing that back out to the CSD system. So all live hardware, all live software.
Appreciate that. We have one more question, or a couple more questions. Back to you, Moshe. Suppose I stream my data to the cloud. Does AnyLog add value in the scenario?
Yes. So when companies wants to bring data to the cloud, they still have an issue of how to get the data from the edge to some kind of a structure that makes sense and is unified. If you are interested to move data to the cloud, you deploy AnyLog at the edge, and then every query that you issue, in the same way that we brought the query result to Grafana in the demo that I've done, you could direct the result of every query to go to the cloud. You could connect it to Kafka and assign it to a topic, which from there you could take it to wherever you want. So the focus in that case is to automate all the work that you need to do at the edge, instead of bringing professional services, DBAs, architects to figure out what's going on. You install AnyLog on the edge. Data comes in, we automatically creates the schema, transform it to a data lake that you could issue queries against it, and you could take any piece of data from there to any process, either at the edge or at the cloud.
Okay, another question that we can bring to the team: how do you manage data security? So Ellie, why don't you give us a quick rundown on the hardware side of it, and then we can talk to the software side of it.
Yes, so from a security perspective, the NGD solution is a standard NVMe device. So whatever protection that you have in terms of a firewall to your server will apply on the NGD solution. We don't provide any special layer on top of what the NVMe provide. And maybe I'll jump also to the question that was asked with Philip about where the actual data was. So this actual POC, NGD set up a server. It's an x86 server with 4 computational storage devices. AnyLog, the next step is we install the AnyLog software on each one of those devices. And so now you have 4 edge nodes in the same server, that each one has its own own node. And then on top of that, Philip installed the AI op and streamed in the data and start working with it live. So the setup is very easy, and that relates directly to what I said in my section about the easiness of the programming model of the NGD CSD.
Okay, and then from a security perspective, Moshe and Philip, do you have any other comments related to data security, since that seems to be a big topic, especially in light of some recent pipeline issues that have existed?
Yeah, and the edge is one of the challenges at the edge is to make it secure. So there are two layers here. One on the AnyLog side, we provide a layer of security where when queries or requests to a node reach out, we're doing two things. First, the AnyLog nodes has a private key, public key. So using this technology, we're able to first identify the requester. So if a node get a request, we're able to authenticate that the request is coming from someone that is the source that he claims he is. So if you, Scott, would send us a message to an AnyLog node, we will be able to validate that it came from you, because we would use your public key to authenticate that you are signed on the message. The next layer says, okay, even though you send me a message, I need to look and see if you're authorized to request what you've requested. And we're using, again, the blockchain technologies and the access to the blockchain data to authenticate that. So one layer of security is the layer that exists inside the protocol, the network protocol. The second thing that I could say, you could deploy AnyLog anywhere that you want, and you could keep your nodes, if you want to, inside your firewall, which is something which is very common in oil and gas. So you've got those two layers. One is a security layer that AnyLog provides, and on top of it, you could keep the nodes inside your firewall if that's the architecture that you want to support.
So on a high level, the computational storage technology is contributing to security from the perspective that the less data movement. So you don't have data in flight. The data is on the storage and is being manipulated and applied to on the storage without moving it. So when the data is moving from the storage to the host, it's more valuable. And when it's sitting in the storage and your application running in the storage, is less a chance and likelihood for someone to interrupt that data.
Right, and from the AI ops perspective, as I mentioned early on in our presentation, we designed everything to sort of live at site with the customer. So for southbound connections, PLC connections, you're talking OPC UA, API access, Modbus TCP. We deploy all the standard security measures around those protocols, and then northbound connections via AnyLog. We would utilize all those security measures that Moshe just spoke about. As far as gaining access to our software or our web user interface, it is an HTTPS connection, user password, user logon logs, so you can monitor who's on, who's not on. All the standard stuff is there.
Awesome, thanks. And we have one more question in the Q&A around APIs. What APIs do you support, and do you support Kafka as one of those APIs?
So AnyLog supports a variety of APIs. So we show the Grafana interacting with the data. So we call it northbound connectors, which are applications that want to pull data. So it's REST API, and we support a bunch of products. And most products today have REST API. So if you want to use Power BI or any other REST-based connection, we would be able to support it. On what we call the southbound connectors, there are a variety of ways to push data into the AnyLog network. Again, this could leverage REST. You could publish on AnyLog data as if AnyLog is an MQTT broker. You could publish data to a third-party broker, and AnyLog would subscribe to the broker and pull the data from there. So again, there are varieties of connectors, and if somebody has specific questions, he could email it to us. We'll be able to look at the specific requirements and address those.
All right, we are at the end of the questions and answers, so we're also at the top of the hour, if you will. So I'll give Ellie, Philip, and Moshe one last chance to give a sign off and a call to action, and then we'll say goodbye for the rest of the day. So Ellie, I'll let you go first.
Thanks. Thanks for the demo, AnyLog and the AIOps. I think it's show the real value of computational storage and help us demonstrate the efficiency of our technology. To take away from NGD perspective, high capacity, low power, quality of service, NVMe SSDs with computational storage capability that are very easy to program.
So I also want to say thank you for all the participants and to our partners, NGD and AIOps. I think, or at least we were trying to show you that we could transform the edge to an environment which could be easily managed and easily interacted, and as an environment which in many ways could be even more efficient in terms of the availability of the data, being able to get insight from the data than the cloud, saving all the transfer of the huge amounts of data from the edge to the cloud. We could together bring the edge to a state where it's operational and a setup that you could connect your applications into it and get insight from your data in real time in a completely automated way. So again, thank you all for joining us here.
Yeah, and just to close out here, thank you both, Ellie and Moshe, for putting this together. Really enjoy doing the demo. And for the call to action, basically, we're in dire need of a controls revolution in the industrial space. This is the perfect use case to jump on and to take a look at. We're definitely trying to close it out with as few clicks as possible and make it an easy to use interface to make the transition as painless as possible. So really appreciate everyone's time and sitting through the entire demo. I noticed everybody hung out, so it was great. Yeah, really appreciate it.
And hopefully, just to wrap it up, you can see the three companies get together, very limited modifications required from any one of the platforms to cohesively come together and create a truly usable end customer direct type of platform and solution. So we again appreciate your time. My thanks go out to all three of the panelists as well, and we look forward to following this up with some future work. So any questions you have, there will be an email that will be sent out as a follow-up to all attendees and registries for be able to watch a replay, as well as be able to contact us with any questions. So again, thank you everybody for your time today, and we look forward to talking to you in the very near future.
Thanks.
Thank you.
Thank you, everyone.